One other thing I needed to address before covering, I didn't really like the way the sides came joined up with the tail post. Even on the plans, you can see that the balsa sides, they come back, and then there's this big gap, and then you've got the rudder. And I thought that was pretty unsightly. I didn't really care for that. So I was in a little bit of a quandary about what to do about that. In the end, I ended up just sanding back. This is the right size, and it's been sanded back for now. I left the left side unsanded just so you can get kind of an idea. This will look much better sanded back, even though I did have to induce a curve in the sanding. I tried to make most of the remove most of the material in the stringers back here where this balsa support is, and just a little bit forward of that, just to kind of blend everything together. Left side is done. Looks about just like the right side. So with the rudder on, to me it looks a whole lot better, or it will look a whole lot better with the covering on. The empennage has a little more twist than what I really would like to have. It's not really bad, and for the kind of flying I'm going to do, it's probably not a big deal. But I'm going to try to reduce some of this twist by adding some diagonals. I have one going on the inside from here to here, here to here, and then on the other side as well. I didn't mention, but this is actually 2 pieces of 2 mm sheet glued up together, and then I stripped 6 mm wide strips. By gluing up 2 balsa sheets, laminating them together, it makes them a little bit stronger than a non-laminated piece. And I have shaped the diagonals to fit along the formers. Diagonals are in. I think it does help stiffen the empennage up a little. The only real twisting I'm getting now is back here with the horizontal stab and fin. And I don't really have a good way to stiffen this part back here up. But I think it'll be okay for my type of flying. Inching closer toward covering, it's time to get some servos mounted, some push rods run. So initially I was going to have my servos in the radio compartment, what the designer has for the radio compartment, pretty standard. And I'm still going to have the rudder servo mounted here. It'll be in the center. And I'm going to run a pull-pull cable, which will cross and then come out to a specialized control horn. But the elevator, I wasn't happy with the push rods, the way they were exiting the fuselage. And it was going to be an awful long push rod run. So I decided to go with the modern 3D way of putting servos in the tail. I'm using Pro Modeler servos. These are, I think it's the DS-105, it's either DL or CL, high voltage. I used 2 of these, one for each elevator. To mount the elevator servos, first thing I have is some 1/32 plywood. It provides a little bit of support so the servo won't crush the balsa. Because this is fabric covering here, I had to have some sort of surface to glue the fabric to as I cut it out for the servo, otherwise, the fabric would fray. So I've cut out a piece of balsa to just kind of fit in between the stringers like so. And I'll attach the fabric to the outside perimeter of the cutout, and I can still get access to the servo mount holes. Back in easy enough. Now to drill my holes. Screws are in place. This whole part is complete. They've been hooked up to the receiver. They are operating in correct rotation. I have the control horn just placed into position. I won't glue these in until after I have fiberglassed the elevators and primed them, so they're basically like this and ready to be painted. At that point, I'll glue in the control horns so they get painted as well, and that's when I'll set up the linkage. One more little detail to add for the elevator servos. I made up a couple of very lightweight paper conduits. The elevator halves on the real airplane are joined in the middle by a bar. It goes from one elevator through a hole in the fin to the other side. And I wanted to add that, but I didn't want to make it permanent because, again, I want to have separate elevator control for redundancy. So I was trying to figure out a way to kind of do this, and what I came up with was to drill a hole in the end. I've done it on both ends, and then use some telescoping aluminum tube, aluminum because it's light. And so the smaller of the tube fits inside the elevator, and these are going to be really loose right now, so it's going to be a little bit fiddly. But then I use a larger piece of aluminum tube, and that slides like so. So, trying to put this all together here. It's a little bit tricky, but when I glue it all up, when I glue in the hinges, I think I'll have plenty of working time. Alright, like I said, a little bit fiddly. And this one hinge right here is just the hard part. Okay. So, with the hinges all glued in, they can both rotate like this. Should something happen with one of the elevator halves, say the servo or the channel or whatever, and one elevator half fails, well, by just having a sliding telescoping tube, they have independent control. So this one could be dead and this one could still work. And this, of course, is assuming that the failed elevator would fail in such a way that the working elevator could override it. Given today's modern radios, though, I know the chances of this happening are very slim. One thing I've learned is never say never. So I realized that I'm going to need to at least glue in the little stub aluminum tube into the elevator halves before I continue on, before I prime or paint. So to do this, I'm going to use epoxy. I'm using my finishing resin because it has such a very long working time. I have at least a good hour. Gives me plenty of time to work. I've added in some adhesive silica. It's, colloidal silica, which is an adhesive filler. And just enough, see, it's not real thick, just enough to kind of thicken it up a little bit. So how to keep my larger diameter aluminum tube from sticking? Well, I'm going to pack it with some Vaseline. Now there's not much of this stub sticking into the elevators, maybe a quarter of an inch. I didn't really need much. You know, this is not structural. It's basically cosmetic. This side with the cutout, this is where the epoxy, I think, is where the filler is really going to help me out. A little bit of tape to the rescue. Alright, now I want them to hang about even. That looks to be about even Steven, so I'm just going to let this sit overnight and we'll see how it looks tomorrow. Next morning, time to see how this idea worked. In the interest of transparency, I have not touched this off camera, so you're going to find out just as I do whether this idea works. All right, first let's see if they'll rotate. Not good. Oh, there we go. I guess a little bit was caught on the tape. All right, so it does rotate, and it looks to be about even. All right, now let's see if it's going to separate. All right. A little bit of, just very small amount of binding, which I think will be taken care of when I clean it all up. Now let's take it apart. I have a little piece of balsa here, which is a filler between the fin and the fuselage. I think I might have to actually remove a little bit of that. So I carved a little bit out on each side. No big deal. This part here is actually going to be covered with a little bit of aluminum can metal, just like the full size has a sheet fairing covering, or a sheet metal covering. So I'm going to do the same. Yeah, this right here is the sticky one. I think I can clean that up. A quick addendum here for those that may be interested. There is a way where you could slide the middle tube into the ends. That is to use a music wire hinge. You would drill out the hinge points and then use music wire. I think 55 thousandths of an inch music wire is a perfect fit, or 58,000, something like that. And then you would have the music wire come through, but then what you could do is you'd put half your hinge in the trailing edge, and then you could slide your middle piece on and then slide in your music wire hinge, and that everything would work perfect there. I want to work a little bit on this last little fairing. I have sort of a roughed out piece. Now what I'm using is a annealed aluminum can. This happens to be beer can, but that doesn't really matter. I like the beer can because it's thin metal. But to anneal it, it's really simple. You just rub some liquid dish soap over the metal and then heat up the other side until the dish soap turns brown. When it turns brown, you've got about the right temperature. And what that does is it allows the metal to be malleable. So you can bend it and it'll hold its shape. Whereas before it's annealed, it's like spring steel, it's gonna spring back. And the only real way to get it to stay is to crease it. But so by annealing it, it'll hold its shape. So I've cut out kind of a template, and it's gonna fit something about like this. A little bit goes on the bottom, and then just gonna kind of gradual taper back to the trailing edge of the fin. I use this is a large handle, X-Acto handle, and to smooth out the annealed aluminum, you just take this and just rub it over it. It'll curl a little bit, and sometimes you can use that in your favor if you need a nice curve, but that'll straighten out a lot of it. And then what I want to use, I want to have a kind of keep this curve right here going back, and then just kind of flatten out. So I'm using, I forget what these sticks are called. Anyway, I'm using this because it's about the right diameter, and I'm just gonna kind of roll it along the stick, and it gives me a nice little curve. And I see I need a little more up front here. Something like this. And then I'll just kind of flatten out the back. And when the glued down, it should hold its shape fairly nicely. Now what I used to cut out this half circular part was just a sharpened piece of brass tube. And with the annealed metal, it's actually very easy to pop out a circle, and then just use a pair of scissors to extend it to the end. All right, I got a couple of them. They're just tack glued in place now. Right one looks pretty good. That one's okay as well. I got some dents here in the middle of it. I think I can pull those out later. This will need to be primed and painted separately and then glued on, like I said, after the elevators are glued in place. But I think this will do a nice job of covering up that last little bit of open space. Another small detail that I want to add that I saw looking at full-size pictures, the real aircraft has covers for the pull cables that come out of the aft fuselage for the rudder. So I'm going to make up something similar. This will be using the plunge method technique with using plastic. So I've made a male plug. It's plywood and shaped, and then I added some body filler, sanded it all nice and smooth. It's been glued to 2 more pieces of plywood as a support, and then I made a female piece which fits over top. It's just a little bit wider than the male piece to give room for the plastic as it goes over the male form. So I'm going to recycle a plastic water bottle. I'm going to try to anyway. I've cut up several pieces of this. I don't think the molded in ridges that come originally with the plastic bottle are going to be a problem. Well, I hate to admit it, but that took far longer than it should have. A couple things I had to do. One, the plastic bottle that had the ridges molded into it, I couldn't use that. That just didn't work. So I had to find a bottle that had a smooth section on it I could cut out. So I got lucky there. I found one. Also with my male form, I had to add some balsa to extend the sides down a little bit. That helped with forming, allowing the side to really come down a little bit. So I finally was able to get 2 decent pieces. I went through almost a whole plastic bottle trying to get to it. I don't know if you can see these, but I'll go ahead and glue these on. They've been roughed up a little bit with some 150 grit paper, allow the primer and the paint to stick to them. So I get these glued on and we'll move on.